Hey, welcome back. Today we're going to be talking about instantaneous power and how you can solve problems using instantaneous power ideas. So let's go ahead and get to it. First, I do want to super quickly review what we mean by power. Average power is what we're talking about when we just generally mention power. That's going to be work divided by time. There is an alternative form to this that I want to tease out a little bit and talk briefly about. So if you say we have power and this work, let's say we've got our force times the distance through which that force is applied. So this is a dot product, you could say, or you could include like cosine of theta between the two vectors that are used when you're calculating work. If you do that and you work with time, you could think of this distance traveled. You could think of this distance through which that force is applied as basically an x. And if that's the case, we could say power is equal to force times delta, let's call it delta x over delta t for a moment. If we do that, what do we know about delta x over delta t? Well, that's like average velocity, right? So another way to calculate average power is if you have force times the average velocity through which that force is applied, or you can throw in a cosine of theta between the two vectors. What I'm talking about is if you have a force applied like this, you travel over a certain d value, certain distance through which that force is applied, and it's a constant force, then you can find this average power. This is your force applied here. Then you can solve for the average power just by figuring out what that is. Notice that delta x over delta t is going to be like a speed or a velocity at which that force is applied, you could say. But let's now focus on what we came to talk about, and that's instantaneous power right here. We do have an equation down below, a problem that we can try. It involves a chinchilla, and so let's say there is a certain amount of work done by a child pushing on a chinchilla like across a floor or something like that, and we've got an equation that governs this action here. And the problem says solve for the instantaneous power done to the chinchilla at t equals 3 seconds. So we're going to say power, instantaneous power, is the derivative of work with respect to time. So if we were going to solve this problem, we could say power is going to be equal to dw over dt. So in this case, power is equal to the derivative of 2t cubed plus 5t over dt. And I'm going to run out of room, but if we do the math, we're going to say power, instantaneous power. Okay, in this case, we would have 6t squared plus 5. And let's say we want to solve for that at t equals 3 seconds. That would mean we would plug in the 3. And here we would end up with an answer of 59 watts. It's actually pretty easy to do if you know your basic derivative ideas. I do want to say I've done screencasts on an entire year of high school physics as well as almost an entire year of AP Physics C mechanics. I hope this was helpful. If you have any questions or comments down below, please let me know. And I hope you all have a great day. Take care.